Welcome to this explainer. Look, if you're gearing up for your distributed systems or IoT exams, you are in the exact right place. We're going to break down the core differences between cloud, fog, and edge computing architectures so you can absolutely ace those tests. Let's get right into it. Here's our quick roadmap for today. We'll start with 1, the cloud baseline, move to 2, edge, action at the source, then 3, fog, the middle ground, and finally, wrap up with 4, the ultimate architectural breakdown. So let's start with a really common question, one you've probably seen thrown around in your textbooks or lectures. Are these 3 terms, cloud, fog, and edge, just fancy different words for the exact same thing? Well, spoiler alert, they absolutely aren't. Today, we're going to discover exactly why the tech industry realized that relying solely on the all-powerful cloud is, frankly, deeply flawed for modern IoT applications. All right, Section 1, the cloud baseline, centralized power. Okay, so cloud computing is essentially a centralized model where data is stored, processed, and accessed via these massive remote data centers. It's totally brilliant for things like big data analytics and machine learning training, mainly because it gives you incredibly elastic scalability and virtually unlimited compute power from literally anywhere in the world. But here's the catch. Imagine you're engineering the software for a self-driving car. An obstacle steps out into the road, the car's sensors detect it, but what if that car has to send that data all the way to a cloud server in another country just to ask, hey, should I hit the brakes? What do you think happens? Well, by the time that data makes the round trip, it's way too late. And this perfectly highlights critical latency delays in situations where milliseconds literally matter. Plus, it exposes massive bandwidth costs, right? Because feeding petabytes of raw video streams over a wide area network will absolutely drain your budget. And let's not forget terrible uptime vulnerabilities. If the internet goes down, your multi-thousand-dollar smart system basically becomes a brick. Not to mention, sending unencrypted data over those long distances opens you right up to cyber attacks. So to solve this massive headache, engineers had to bring the brain closer to the body. That brings us to Section 2, edge, action at the source, zero latency. This right here is a completely decentralized architecture. It pushes computational and storage resources directly to the endpoints, exactly where the data is being generated and consumed. So instead of sending raw video feeds all the way to the cloud, edge computing processes that data on small form-factor hardware, industrial PCs or embedded systems right at the source. To picture this, think of an Amazon Go store. You've got hundreds of cameras tracking inventory and customer movement locally. If they tried to send all that raw 4K video up to the cloud, it would crash the network in seconds. Instead, local edge devices instantly deduce that, hey, you just grabbed a can of soda, and they send only a tiny, light-rate data packet with a $2 charge up to the cloud. It's so much more efficient. In this decentralized approach, it gives us some incredible benefits. We get zero latency for instant real-time decisions. We get massive bandwidth conservation since we're only sending the results, not the heavy raw data. And maybe best of all, we achieve total autonomy. Your system keeps working perfectly, even if the Wi-Fi completely drops. But wait, what happens when you have thousands of local edge devices that need to coordinate with each other, but they lack the processing power to do it alone? Well, that brings us to Section 3, fog, the middle ground, bridging edge and cloud. Introduced by Cisco, fog computing acts as this crucial middle ground. It's a distributed computing paradigm that actually extends cloud capabilities right down to the local area network, or LAN. So while edge processing happens directly on the sensor itself, fog acts as a bridge. It utilizes intermediary nodes. Think network routers, switches, or local IoT gateways that are sitting just a single hop away. Let's look at a smart city traffic monitoring system as an example. First, you have edge cameras checking local intersections to see if cars are waiting. Second, because those individual cameras can't see what's happening at the next intersection over, they send their data to a fog node router right there on the street corner. This router aggregates the data to quickly synchronize the green lights for the entire neighborhood in real time. And then third, that fog node securely sends just a tidy daily traffic summary up to the cloud for long-term urban planning. See, it handles all the time-sensitive analytics and filters the data before it ever even touches the cloud. All right, now that we've mapped out all 3 of these paradigms, it's time for Section 4, the ultimate architectural breakdown, your definitive cheat sheet. If you want to absolutely crush your exams, this right here is what you need to memorize. Let's compare them across 4 key metrics. For location, edge is right there on the device, fog sits on intermediary routers, and cloud is totally remote. For latency, edge gives you that ultra-low, zero latency, fog is slightly higher but still real-time, and cloud is obviously the highest. As for processing power, edge is limited by its physical hardware, cloud gives you infinite scalability, and fog perfectly balances the two. And finally, security. Edge gives you solid hardware-level security, fog enforces local encryption, while cloud carries a much higher risk just due to that long-distance data transmission. To wrap this all up, remember that modern IT infrastructure doesn't force you to just pick one of these. It actually uses all three. You take the red pill for immediate, real-time edge reality. You take the blue pill for massive cloud scalability and big data. Or you take the purple pill of fog computing to securely bridge them both together, filtering and managing data locally. As you study these amazing architectures, review these real-world examples, and prep for your tests, I want to leave you with one final thought to explore today. Just take a look around your house right now. How are the smart devices in your very own home balancing the edge and the cloud right at this exact moment?